overview of the chapter. So we divided become 3 types. First, we need to know the evaluation of limits. Second one, as integral, and third one is continuity. For the evaluation of limit, we will divide it become polynomial expression, regular expression, and also the existence of limit. Existence of limit is very important in helping us. So the second part will be vertical or horizontal asymptote, which is related to infinite limit and value limit at infinity. The last one is the continuity test and also continuity at the time. So are you ready? So if you are ready, let us start from the first one, definition of limits. So if a function f(x) becomes closure to a single number L, so as the s approaches to a, so a here means is an element of real number. So from the diagram, we can get to know that the either side here is mean left side and right side, which is denoted by using a negative and positive. So from the function and also the curve, we found that both sides also stop at the L. So we can say that the limit of the fx as s approaches a is f. So let's look at example 1. This is a linear function. So as we know that from the animation, the diagram, we found that the movement of the blue point is stopped at the y equal to 3. This is show that the left side limit equal to 3, right side limit equal to 3. So the final limit of function fx exists with the values of 3. So let us move to the second type of function, which is piecewise functions. This means that the function divided become more than one interval. So in this situation, the 2 is the boundary number. So the left side and right side, when s approaches 2, we found that it's also stopped at the y equal to 3. So we can say that the limit of the function gx when s approaches to 2 is 3. Existence of limits. So we are going to solve by using the test of existence of limit. So based on the definition, you will find the left side, right side limit must be equal to L, and you only can conclude that the limit exists at the value of L. So based on this example 3, so when the s approaches 1 from left, from the diagram we found that approaches 1 from the left is a constant function with a horizontal line, and the y value is negative 2. So when the limit approaches 1 from the right, okay, so we have another values of y equal to 2, but the 2 is not related to x equal to 1, because we are going to find the values of y when the x is getting closer to 1 from the right side. So don't get confused with it. So from these two-sided limits, we can say that the limit exists. So example 4, it will be another example which is the limit does not exist. So it's very obvious that the two functions is not linked to each other. So from the left side function is at the bottom horizontal line where the y is equal to negative 3. But for the right side function is at the top with a constant value y equal to 3. So based on the test of existence of limit, it does not fulfill the situation. Therefore, we can say that the limit as approaches 1 for the function gx does not exist. So all these two are opposite example. So let us proceed to another example. When the function looks continuous, but the x value is different. Okay, so this is the example. Okay, the question is given that the x value is equal to 0. So we would like to write it down as from the diagram. When the x approaches to 0 from left, we are going to focus on left side of the graph. So when approaches 0 from the left, the curve is stopped by the values of y equal to 4. So the left side limit is equal to 4. So same goes to the right side. We are going to focus on the right side of the curve when approaches to 0. So from the curve, we also get that when approaches 0 from the right side, the function also stops at y equal to 4. So what is the conclusion? Yeah, that's right. You will find that the limits exist with the values equal to 4. So this three example is a graphical method in finding or evaluate the limits. So let us proceed to the last example. Okay, did you notice that there is no diagram or graph provided, but we only given a 3 different functions with the 3 different intervals. So we can sketch a graph, but we also can use another method, which is algebraic method. So what is the first thing we have to do is we have to determine what is the boundary numbers. So my dear, if you look at it, the boundary number here obviously is a -1 and 1. So what we're going to do now is try to draw a timeline and label the boundary number, and also fill in the blank the corresponding function based on their interval. Okay, so from here, after we identify the corresponding function, please look at the question. The question is asked us to evaluate limit when the x approaches to 1. So means that there are two functions, x squared and 4 minus x squared are related. So we will start from the left side limit. When the x approaches 1 from left, the corresponding function is x squared. So after you substitute, we found that the limit is 1. So same goes to the right side limit. The corresponding function is 4 minus x squared. So from here, after we substitute x equal to 1, we get that is equal to 3. So obviously, the left side and right side limit are not the same. So what is the conclusion we can make is, we have to write it down as since left side limit not equal to right side limit. Therefore, the limit when x approaches to 1 does not exist. So these are the two things that we learned from this video. Hope you understand about it. See you. Bye.